China's upcoming Mars mission in 2028 represents one of the most ambitious efforts to explore the Red Planet, aiming to surpass previous milestones in space science and bring humanity closer to unlocking Mars' secrets. The mission, spearheaded by the China National Space Administration, CNSA, includes both a Mars sample return and advancements in orbital and surface research capabilities. This mission follows the success of Tianwen-1, which placed an orbiter around Mars and deployed the Zhurong rover to the surface, and builds on the insights and infrastructure CNSA has developed in recent years. The journey to Mars will be propelled by a new generation of launch vehicles that enable heavy payloads, allowing CNSA to send advanced equipment and technology for both sample collection and long-term study. The launch vehicle's payload will carry an orbiter, a lander, a surface ascent vehicle, and a return module. The orbiter will play a crucial role in providing real-time data and communication support throughout the mission. Once in Mars orbit, it will facilitate the release of the lander, which will descend onto the Martian surface. The orbiter itself will remain operational for an extended period, conducting high-resolution imaging and mapping of the Martian terrain and atmosphere. It will also function as a relay station, ensuring data from the lander and ascent vehicle can be transmitted back to Earth, a vital component of the mission's success. Upon landing, the descent module will deploy advanced robotic arms and instruments designed for sample collection. CNSA has planned meticulously for this phase, investing in technology that can collect subsurface samples, providing new insight into Mars geology. The robotic arm will penetrate the Martian surface, collecting rock and soil samples from various depths to capture a wide-ranging profile of Martian soil. The instruments on the lander will analyze the planet's surface for chemical, geological, and potential biological indicators, possibly revealing clues about the past presence of water or microbial life. The data will serve as a crucial resource for scientists on Earth, who hope to understand Mars' geological evolution and potential for hosting life. Once the sample collection is complete, CNSA has planned an unprecedented Mars ascent vehicle launch from the Martian surface. This ascent vehicle is designed to carry the samples collected back to the orbiter, where they will be transferred to the return module for the journey back to Earth. This ascent, a complex maneuver, requires advanced engineering to ensure the samples can be transported securely through Mars' thin atmosphere and rendezvous with the orbiting return vehicle. The ascent vehicle must be compact yet robust, equipped with a heat shield and navigation systems capable of executing precise docking procedures. It is a critical part of CNSA's mission design, with strict safety and containment measures in place to preserve the integrity of Martian samples and prevent contamination. The return journey will present its own set of challenges, including navigation through interplanetary space and re-entry into Earth's atmosphere. The return module is designed to endure the intense heat of re-entry while ensuring the samples remain uncontaminated and protected from Earth's environment. This mission phase will provide a wealth of data for CNSA, further refining their expertise in space return technologies. Upon re-entry, the module will deploy parachutes to slow its descent and will be recovered in a predetermined landing zone in China. CNSA has designed this phase with extensive precision, ensuring the sample's safety and scientific value. CNSA aims to conduct extensive analysis on these samples, offering insights into the formation of Mars and the potential for life on other planets. China's 2028 Mars mission will symbolize a new era in planetary exploration, not only for China but for humanity. By returning samples from Mars, CNSA will provide scientists worldwide with an unprecedented opportunity to study Martian materials directly, enabling a deeper understanding of Mars' past and present. These analyses will contribute to human knowledge about planetary processes, the conditions that foster life, and the differences and similarities between Earth and Mars. This mission will inspire future explorations, opening the door for even more ambitious planetary missions. As China demonstrates its capabilities in space exploration, the mission will underscore the growing role of international collaboration in unlocking the mysteries of our solar system. China's 2028 Mars mission is expected to serve as a foundation for even more ambitious space endeavors in the coming decades, marking a significant step toward deeper space exploration and the search for extraterrestrial life. This mission will not only demonstrate China's ability to execute complex interplanetary operations but also lay the groundwork for future missions that will delve even further into Mars' environment and geology. As CNSA engineers and scientists tackle the challenges of returning Martian samples, the mission's success will also establish international confidence in China's space program and may inspire global partnerships aimed at more comprehensive explorations of Mars and beyond. In preparation for the 2028 Mars mission, CNSA has developed new, advanced technologies and mission protocols to ensure the successful retrieval and transport of Martian samples. This includes rigorous testing of the ascent vehicle and return module, which are designed to operate autonomously in one of the most challenging environments in our solar system. Engineers are fine-tuning navigation systems and thermal protection for Mars' thin atmosphere, ensuring the ascent vehicle's stability as it lifts off from Mars. Meanwhile, the CNSA research team has been developing cutting-edge techniques to preserve sample integrity, preventing any potential contamination that could compromise the scientific findings. This groundwork will also feed into future missions with even more ambitious targets, possibly including manned missions or multi-planetary sample retrievals. Beyond scientific discovery, China's 2028 mission will bolster the nation's position in global space diplomacy, fostering a spirit of collaboration with other space agencies. By openly sharing mission objectives, CNSA has paved the way for cooperation with other scientific communities and agencies such as NASA and ESA. This collaboration has the potential to standardize methods for planetary sample handling and interplanetary mission protocols, setting the stage for more collaborative endeavors across spacefaring nations. By extending an invitation to the international community to collaborate on research, CNSA is opening doors for cooperative projects that may shape humanity's collective approach to exploring Mars, potentially accelerating the timeline for human exploration and settlement on the Red Planet. The 2028 mission also plays a critical role in advancing CNSA's long-term vision of establishing a human presence on Mars. With the increasing feasibility of human exploration missions, this mission will serve as a testbed for the technologies and techniques required to support human life on Mars. The extensive data gathered on Mars' surface and atmosphere, along with sample analyses, will inform habitat design, resource extraction, and environmental adaptation strategies that future Mars missions will need. These insights will be crucial for developing self-sustaining human habitats, possibly making Mars a future frontier for human civilization. Additionally, this mission aligns with CNSA's vision to build a multi-planetary society, where knowledge gained on Mars can be applied to other extraterrestrial bodies. China's 2028 Mars mission is a testament to CNSA's commitment to advancing humanity's knowledge of Mars while demonstrating a growing mastery of the technologies needed for complex, long-duration space missions. This undertaking will expand China's influence in space exploration, affirming its role as a key player in the 21st century space race. Through the collection and analysis of Martian samples, CNSA aims to contribute significantly to our understanding of planetary evolution and life's potential beyond Earth. As CNSA refines its expertise, the mission's success may well redefine our expectations of what is achievable in space exploration, sparking a new era of innovation and interstellar possibilities. The upcoming mission represents a leap in understanding the solar system's dynamics, with an eye toward future resource utilization and planetary defense initiatives. Mars, with its abundant natural resources and unique geology, holds the potential to be a hub for future space resource extraction efforts, and data from the 2028 mission will illuminate which resources are most accessible. If successful, CNS's mission will provide the essential data required to assess Mars as a viable target for resource extraction, potentially fueling future space infrastructure and enabling other planetary missions. Insights into Martian geology and resources may also inform Earthbound industries, from mining technologies to environmental sustainability efforts, marking this mission as a significant step in humanity's journey toward becoming an interplanetary species. China's Mars mission in 2028 aims to deepen our understanding of Mars' climate history, revealing insights into how the planet's atmosphere has changed over billions of years. By collecting samples from different layers of Martian rock and soil, CNSA hopes to uncover records of Mars' ancient climate. This data could indicate whether Mars once had a denser atmosphere and liquid water, which are essential for life. Scientists will examine the isotopic compositions of gases trapped in Martian minerals, hoping to decode how Mars' atmosphere evolved and what factors led to its present thin, arid state. This research is pivotal for understanding the conditions necessary for sustaining life, helping scientists hypothesize what Mars, and perhaps other planets, may have once looked like. In addition to climate history, CNS's mission will explore Martian seismic activity, providing a window into the red planet's geological dynamics. CNSA has equipped the lander with specialized seismometers to measure ground vibrations and potentially detect Marsquakes. By studying the frequency and intensity of these quakes, scientists can deduce details about Mars' internal structure, including its crust, mantle, and core composition. Analyzing Martian seismic activity will give researchers new insight into the tectonic processes that have shaped Mars, helping us understand how Mars and Earth compare. The findings from this study will also offer clues about the planet's cooling history, shedding light on its evolution and helping scientists assess Mars' potential for volcanic activity. The Mars mission also includes a focus on investigating surface radiation, which is essential for future human exploration. Mars' thin atmosphere offers little protection from cosmic rays and solar radiation, making it a challenging environment for potential human missions. CNSA will deploy radiation detection instruments on the surface to measure radiation levels and assess how Martian soil may provide natural shielding. This data is vital for the design of habitats and protective gear for astronauts in future Mars missions. Understanding the intensity and distribution of radiation on Mars will inform strategies for long-term human habitation, helping CNSA and other space agencies plan missions that prioritize astronaut safety and resilience against Mars' harsh environment. CNS's 2028 mission includes an advanced study of Martian dust, which is critical for understanding the planet's extreme weather patterns. Mars is known for its massive dust storms, some of which cover the entire planet for weeks. The mission will investigate the composition, size, and behavior of dust particles in Martian soil and atmosphere, which will help researchers understand the forces that drive these dust storms. Studying dust behavior is crucial, as it affects solar panel efficiency, robotic equipment, and possibly even human health in future missions. By uncovering the mechanics of Martian dust storms, CNSA aims to develop technologies to mitigate dust-related challenges, ensuring the longevity of Mars missions and improving the feasibility of establishing sustainable habitats on the planet. The 2028 mission represents a leap forward in our search for ancient microbial life on Mars. CNSA has designed sophisticated biochemical sensors and drilling technology to search for organic molecules within Martian rock samples. These organic compounds, if found, could indicate that Mars may have once hosted microbial life, providing groundbreaking insight into the existence of life beyond Earth. This exploration will build on the preliminary findings from previous Mars missions, aiming for a more conclusive understanding of Mars' potential biosignatures. Detecting preserved organics, amino acids, or other biochemical evidence would be one of humanity's most profound discoveries, supporting the theory that life may arise under certain conditions beyond Earth. Such a discovery would redefine our place in the cosmos and expand the possibilities for life on other planets and moons within our solar system.